Okay, so this first one, we're supposed to evaluate the 6 trig functions. So we'll start with sine. We know sine is opposite of our hypotenuse. Well, if we look at this picture, we don't even know what the hypotenuse is yet. So we're going to have to do a little Pythagorean theorem on here. So one of the legs is 6, the other leg is square root of 85. That whole square root of 85 will need to be squared. Square of 6 is 36. When you square a square root, squares and square roots are inverses of each other, opposites of each other. They cancel each other out. All you're left with is 85. So we've got to add 36 and 85, giving us 121. So we've got c squared equals 121. When we square root that, we get that c is 11. So that's your hypotenuse of this triangle. We do need to know which sides are opposite, adjacent, opposite, adjacent, hypotenuse. So I'm going to label accordingly. So we know 11 is the hypotenuse. And opposite and adjacent are in reference to theta. So 6 is next to theta. It's that side right next to it, so that's the adjacent side. The square root of 85 is across the way. It's the opposite leg. So sine, we know, is opposite of our hypotenuse. We put opposite on the top. Opposite of our hypotenuse, so hypotenuse goes on the bottom. So square root of 85 over 11. There's our sine. Cosine, we put the adjacent over the hypotenuse. Adjacent is 6, hypotenuse is 11. Tangent, we put the opposite over the adjacent. Square root of 85 over the 6. And then the other three are their inverses. So cosecant, not inverses, but reciprocals. Reciprocal of sine, 11 over square root of 85. And secant's the reciprocal of cosine, so 11 over 6. And cotangent is the reciprocal of tangent, so 6 over square root of 85. Moving on to number 2. So the triangle, we know a little bit of information. Maybe I'll write these pieces of information right on the picture. B is 42 degrees. Side C is 17. We know it's a right triangle. We have to solve the triangle, find everything that's missing. So I'm missing angle A, I'm missing side A, I'm missing side B. Those are the 3 things we're going to have to find. We know all 3 angles add to 180. This one's 90. So that means A and B have to add to 90. They're complementary. So A has to be 48 degrees. So now I need to find side A and side B. So side A, I'm gonna go off of the 42 degrees because that's the one that was given to me. A is adjacent. And C, I know what C is. C is the hypotenuse. So I want to use 17. I don't want to use B because I don't know A or B. I can't compare them both. So I compare A to the one I do know. So A to C. So adjacent and hypotenuse, that's a cosine problem. So let's write it down. Cosine of 42 degrees is equal to adjacent over hypotenuse. So it's A over 17. Put cosine of 42 over 1 so we can cross multiply. A gets multiplied by 1, so 1A is just A, equals 17 times cosine of 42. We'll plug that in the calculator. You want to make sure that your calculator is in degree mode. So I'm going to go to mode here, and degree is right here. It's a little hard to see on there, but it is highlighted. So I know I'm in degree mode. So I'm ready to go. So I will hit 17 times cosine of 42. And my answer then would be 12.6. It doesn't say how much to round it to, so I'll just round it to the nearest tenth. So A is about 12.6. So now I have to find what B is. So now I don't want to use A. I don't want to use the adjacent side. I want to use B, which is the opposite side. And I still want to compare it to 17. I could compare B to A now that I know what A is, but 12.6 is rounded and it's not nice. 17 is nicer and it's exact. So I'd rather use my hypotenuse. So we're going to compare the opposite and the hypotenuse. That's a sine problem. So set up the equation. Sine of 42 degrees is equal to your opposite, which is B, over the hypotenuse, which is 17. Put sine of 42 over 1, cross multiply. 1 times B is equal to the other cross product, 17 times sine of 42. Pull out the calculator. We're going to do 17 times sine of 42. And we get about 11.4. So finished with question number 2. Number 3, we have to draw a picture. There's a flagpole, so flagpoles go upright. And I cast a shadow on the ground. So there's a shadow on the ground from, here we'll draw along the ground. Let's say this is the shadow. We know the shadow is 37 feet long. We would assume that the flagpole and the ground are perpendicular to each other. And they talk about angle of elevation. So if I just connect this line, it's just an imaginary line from the top of the flagpole to where the shadow hits. That forms an angle of elevation right there. So they say that that's 36 degrees. We have to find the height of the flagpole, so I can call that x. Well, on this right triangle, I'm looking for x. I see that that's opposite of the angle of elevation, so we'll call that the opposite leg. 37, meanwhile, is a leg. It's adjacent. It's touching the 36. So opposite and adjacent is a tangent problem. So tangent of your angle is equal to your opposite, x, over the adjacent, 37. Put tangent of 36 over 1, cross multiply. 1 times x is x, equals 37 times tangent of 36. We'll plug that in the calculator. 37 times tangent of 36. 26.9 feet. That's about how tall it is. So about 26.9 feet is our answer. Now they want us to draw in standard position. When you draw in standard position, you start, the initial side starts on the x-axis, the positive side of the origin, and we have to go negative. If it was positive, we go counterclockwise. This is negative, so I have to go clockwise, 300 degrees. So I go 270, and then 30 more than that. So it puts me about right there. Number 5, 5 pi over 6. So this is in radians. Since you're probably not as familiar with radian measure, you might want to convert it to degrees. We have some of those problems on the back side of this in a little bit, so we can practice that right now. If you're not familiar with what that is, convert it to degrees. So to convert to degrees, you multiply by 180 degrees over pi, because pi is the same as 180 degrees. When you do this, our pi's can now cancel. And then that 180 and the over 6, those can simplify. They're both divisible by 6. 6 divided by 6 is 1. 180 divided by 6 is 30. So now I have 5 times 30, which is 150 degrees. So they're talking about a 150 degree angle. We have to graph that. So we start at the origin, go to the right. That's our initial side. It's positive, so I'm going to go counterclockwise this time, 150 degrees. So that ends up being 30 degrees short of 180, so about there. Let's go to the back page. Find a positive angle and a negative one that are coterminal. So to find coterminal with 470, you can add or subtract 360. So if I add 360 to 470, if you take 470 plus 360, we get 830. That is an acceptable answer. That is not the only answer. You could give 830 degrees. If we subtract 360 degrees from 470, if I take 470 minus 360, I get a positive 110. So that would have been another choice for positive. You only do one of these, so you choose which one. But that's for the positive. You could do them both, I guess, but they're both positive. To do a negative, you're going to just subtract 360 again, and there's a negative one. So you can give either one of the positive ones, and then you can give that negative one. For conversions, We talked about this a little bit on the other side. To go from degrees to radians, I'm going to multiply by pi over 180. So I can put 270 over 1. 270 and 180 are both divisible by 90. 3 times and twice. So now when I multiply, 3 pi is my numerator. My denominator, 1 times 2 is 2. So I get 3 pi over 2 radians. So for this one, I go backwards. I multiply by 180 degrees over pi, similar to what I did on the other side of the sheet. Pi's cancel. 3 and 180 can simplify. So I end up with a numerator of 2 times 60. That's 120 degrees over 1. So 120 degrees is my answer. Number 9, let's plot this point. -4, up 3. I'm going to connect it to the origin, and I'm going to make a right triangle. So the right triangle should always be made with the x-axis. So we went 4 to the left, so I'll call the x-axis -4. I went up 3, so I'll call the y part of the vertical part 3. If you do Pythagorean theorem with those, put -4 in parentheses because we don't want to forget about the negative sign. 9 plus 16 is 25. So C is 5. That would be the hypotenuse. So now I need to do the 6 trigonometric functions of that angle. So the angle is the angle that it makes with the by the origin there. So we want to do opposite over adjacent, or opposite over hypotenuse for our sine, 3 over 5. Cosine's adjacent over hypotenuse. Tangent's your opposite over your adjacent. I don't want to put the negative in the denominator, so I can just move it out front. So I'll just call that -3/4. So for cosecant, just reciprocal sign, so 5 over 3. For secant, reciprocal cosine, put the negative in front so I don't have to put it in the denominator, so I'll call it -5 over 4. And then for cotangent, keep the negative out front, so flip the 3 and the 4, so it's 4 over 3. Number 10 and 11, we simply plug these in the calculator. So I'll do second cosine of 0.43. I get 64.5. I'll just call it 65 degrees. I'll go to the nearest degree. So 65 degrees. But it says we also wanted radians. So to convert that to radians, I have to multiply by pi over 180 degrees. So 65 over 180. They're both divisible by 5, so I get 13 over 36. So 13 pi over 36. That's what that would simplify to in radians. So now for sine, we do inverse sine of -0.21. So inverse sine of -0.21, we get -12.1. It's -12 degrees. It is okay for it to be negative. That just means if you graphed it and stay in a position to be in the 4th quadrant, we can have a negative measure. It's okay. To convert that to radians, once again we multiply by pi over 180 degrees. So 12 and 180 simplify to 1 and 15. So I get -1 over pi, so negative pi, rather, for a numerator, over 15. Okay, almost done. Number 12. We have 2 sides we know we're looking for the angle. So let's think about what sides of the triangle they are. 5 is opposite of theta, and 8 is the hypotenuse. Opposite and hypotenuse is a sine problem. So sine of the angle is equal to the opposite over the hypotenuse, but since we want to get the angle by itself, I have to do the inverse sine of the fraction. I have to do the inverse sine of 5/8. So on the calculator, that's second sine of 5 over 8. We see that's about 38.7 degrees, depending on what we round it to. It doesn't tell us, so I'll go 38.7 degrees. Number 13 is a non-right triangle. Notice they're not right angles. So we're going to have to use law of sines here. First thing you might do is find out the missing angle. We know 2 of the angles, So we know if we subtract 71 and 29 from 180, we get the missing angle. So we see it's an 80-degree angle. That's one of the things we're trying to find. Angle A is 80 degrees. Looks like we already know side A, because A's are opposite each other. So here's B, so we go opposite B, here's side B. We don't know that. That's one of the things we're looking for. If you go opposite angle C, side C is over here. We don't know that either. So we're now going to try to find side B and side C. So law of sines. Since we know both A's, we have to use the A part of law of sines. So sine of angle A over side A. So angle A was 80, side A is 15. And then we choose whether to use B's or C's. I know one of the B's, so I can use B's. Sine of angle B is 71 degrees. Over side B, I don't know what side B is, so I'll write it that way. And we'll use cross multiplication. I'm looking for B, so I'm going to start there. It gets multiplied by sine of 80. So I'm going to write B times sine 80. I always like the sine part to come last. That's why I did it in the order I did it in here. And then on the other diagonal, 15 and sine of 71 get multiplied together. I want the sine part last, so I'll put 15 first. 15 times sine of 71. I'm trying to get B by itself now, so now I see it's multiplied, so I have to divide by sine of 80. So now let's plug this in the calculator. So 15 times sine of 71. Notice, 71. Notice it started parentheses before my 71, so I need to end the parentheses before I divide. So divide by sine of 80. I see that's about 14.4 for B. And now I need to find C. So I'm going to do another law of sines problem. I will start with the A's again since I know both of those. And then I'll use C's because I need to find one of those. So sine of angle C, that's 29 degrees. Over side C, I don't know that, so I'll cross multiply. So C gets multiplied by sine of 80. Okay, last step. Divide by sine of 80. That's going to give us our answer. So let's plug that in the calculator. 15 times sine of 29 degrees divided by sine of 80 degrees. We get about 7.4. So there are our answers for number 13.